Thank you, Jim. Alle som her har jo hørt meg, da, det var bra. Men velkommen til dere som sitter hjemme da, som ikke har pizzaøl her. Derfor glemte vi å ta vekk muten. For her sitter vi og koser oss skikkelig. Dagens program, jeg skal bare endre litt på rekkefølgen, siden vi har med oss Jim fra Nashville, Tennessee. Og der jo da klokka, nå jo litt over 4 her, så den litt over 9 om morgenen. Så han skulle i noen andre møter, mens vi jo ferdig for dagen. Og så går vi over til Roar etterpå, fra NBIM, eller populært kalt oljefondet, eller vår fremtid, vår sikkerhet. Og så skal jeg ta en liten, bare det beste fra Tableau Conference, som var nå i Las Vegas, og virtuelt for noen uker siden. Jeg skal bare ta en liten highlightene derfra. Og så tar vi en liten sånn wrap-up, og når vi da ferdig, så hvis det noen som har lyst til å være med ut etterpå, så har vi booket et bord på en pub som 6 minutter herfra. De som ikke har lyst til det, eller sånn så enkelt, skal ikke nevne navnet som var ute i går, som sikkert bare skal hjem og slappe av. De kan få lov til det også. Jeg var på den samme plassen, jeg gikk og la meg litt tidlig. Da kommer lyset inn. Going to introduce Jim, former Zen master, but that's not politically correct to say anymore. So now he's a Tableau visionary. There's also a Tableau ambassador. Met him in Las Vegas, of course. We had some fun over there. Half of the people from the community, when they came home from Vegas, had COVID. I didn't. How did it go with you, Jim?
Fortunately, I had 4 negative tests, but I was not feeling very well at all. I had some sort of sinus infection, but it was pretty scary.
Yeah, there was a lot of people, getting COVID after that trip. I don't know why, but people, alcohol together, something about that. Normally, Jim, when I introduce people that are from abroad, we have this big picture of the community, and please find him or her in the Finding Waldo. We didn't find any of those pictures, so Mr. Jim here, if I manage to find where my marker is, over there. This is from the Tableau community page. All of you are brilliant Tableau users, so obviously you don't need to get help from anybody. You do it on your own. But if ever you get stuck, use the community, put in your questions, and there will be people like Ken or Deepak or Diego that will help you, and you get a reputation badge in here. Obviously, that's the more people you help, the more praise you get and a higher badge. And the reason why I don't have number 1 in here, I guess you can guess who it is. So for you guys at home and you guys in here, we're going to do 1 gift or Tableau swag for the one at home and 1 from here, which is the how many of best answers have Jim had over time on the community page. So you guys on the that are home, you can put it in the chat window, give your suggestions. The one who are closest will get some Tableau swag. And the same for you guys in here. I'm not sure how we're going to do that though, but because I don't have any pen or paper or anything. I think it's a bit more than 3,308. It could be 1 more, it could be many more.
7,000.
3.5. 3.5. 3.9. Anyone else? Sorry? 8,200. Jim, you have to work on here. We have suggestions from 3,900 up to 8,002. Anyone else? 5,600. 10,000. Anyone who haven't given a suggestion?
4,100.
5,100. 4,100. Okay, there's nobody on the chat who are volunteering to. They don't want to win any swag, so that's good for you. So then, if there won't be anybody in the chat who will give me a number, well, if 1 do it, then they will win. So I mean, they will be the closest anyway. but either they can't hear me or they are not bothering. So let's see. Do you know yourself, Jim, how many you have?
Actually, I don't.
3,801.
3,800.
Yeah.
And I think there were a couple more this morning, Tori. So, you know, if it's close.
Yeah, so then you are the VIP with Insight Pro. In here, you have this badge over 7,900 points that you're collecting in here. You can search for my name in here, and I'm on 800 and something place. I can't. I don't know how you have time to do that, Jim. I'm on the off the charts badge, so I still have a way to go. So I think well, you were closest, weren't you? 3,900.
That's my first swag.
Yeah.
Ever.
And you're going to be presenting afterwards, and then you're also going to get some swag, so it's going to be doubled today.
Maybe two.
Okay. So Jim is going to be, I'm going to stop sharing my screen so you can take over. He's going to be presenting order of operations. And we had a discussion earlier, or I had earlier with Jim as well, that I would have loved to know way more about order of operations when I started working with Tableau. It took me many years before I realized how important that actually was. So now, Jim, who also is a Tableau ambassador, a user group leader from Nashville, Tennessee, is going to be presenting the order of operations for us. And then we'll start some Q&A if you have any questions, or you have big eyes and don't understand anything.
Okay, I'm going to share my screen now, and you should be able to see this. And first, thank you for letting me speak with your group today. This is an absolute thrill. I told my wife I was going to speak with this group, and right away she started packing. I said, no, it's virtual. And she was very disappointed, so she hasn't spoken to me in a week. So we will go on from there. This is, when Tori and I talked about speaking, I said I wanted to speak on the order of operation. The order of operation to me is probably the single most important facet or fundamental of Tableau that you really need to understand as a new user. I did a series, and maybe some of you have seen the series out there. I called it Zero to Zen. I did it about a year and a half ago or 2 years ago. And it covered the 5 basic fundamental things. And these are the 5 things here. The 5 fundamental things that I needed to understand coming from an Excel environment before I really felt comfortable using Tableau. I'd been working with a client, and it's a client I still work with. I'd worked with them for a number of years, and they said, look, we want you to learn Tableau. And they said, I don't want you to worry about it. It's just exactly like Excel. You'll have no trouble doing it. And of course, about 2 weeks later, I thought I was lost. I was just absolutely dumb as a box of rocks because I could not figure out Tableau at all. And finally, I realized that it wasn't at all like Excel. And there were some fundamental things that I really had to understand before I could go on and use Tableau successfully. The order of operation is the second of those fundamental things. And in my estimation, it is probably the most important to understand. I teach it a little different than most people do. So I hope this is beneficial to you. I have recommended to many a new user to print out the order of operation, yes, on a piece of paper, and keep it next to your computer there so that when you run into trouble, things aren't working the way you think they should, you can go back and look at the order of operation, because for the most part, the problem lies in trying to do something out of sequence. Okay, so what is the order of operation? Well, I use a 10-step model, and I realize there's a number of different models, but I use a 10-step model. And the order of operation is nothing more than the sequence that Tableau goes through as you create each one of your worksheets. Now, if you think about what's happening here is you load some data into Tableau, and you can load it in off of a flat file or some sort of database. And then for each one of your worksheets, you're going to take a subset of that data. And that subset of the data is the only data that's available for that specific worksheet. Now, when you create that subset, you're actually creating something, and you can kind of think of it like an Excel spreadsheet. It really doesn't look like that, but you can think of it like that. And the first thing you're going to do is you're going to create a structure for that worksheet by dragging headers the same way you would in Excel, by dragging headers to rows and columns, and it forms a structure for the worksheet, and you end up applying some filters, and now you've got the structure set. Okay. Now you've got the structure set for that worksheet. And the remainder of what you do is just put values in the worksheet and decide what it's going to look like. Now, I like to look at the order of operation as 3 distinct groups. In those 10 steps, the first 2 steps in the order of operation operate at the workbook level. And they're there as data source filters and extract filters to limit the amount of data that's going into your worksheet or into your workbook. And it makes a whole workbook perform better if you don't have data in there that you're not going to use them. The remaining 8 steps work at the worksheet level, and each worksheet has its own specific data table. Steps 3 through 5, and this is where most problems occur with new users. That's in steps 3 through 5 is where you create the structure for that data table. And that's using context filters, the top end, and dimension filters, top end and sets and fixed LODs and dimension filters. And then the last 5 steps, all we're doing is we're going to put values into that data table. We're going to fill the data table up with values. Then we're going to do some math. And then in addition to doing some math, we may calculate some totals and we decide what the viz is actually going to look like. We're going to take a look at each one of these steps independently, and then we'll come back and answer some questions if you've got them. Now, these first 2 steps really work the same. They're extract filters and data source filters. And as I said before, they work at the workbook level. And their whole purpose is to reduce the amount of data that you bring into Tableau. And then your performance is going to be going to perform better. You would create them. This just looks at a simple set of Superstore data. And if you look at the data, right now there are 10,000 records, and I'm just taking a look at the View Data tab here off the analysis. Okay, and you can see here we've got a total of, this is a new interface if you haven't seen this, but this is a new interface here. We've got a total of 10,000 records in the data set. And that's how many records we brought in. We can go out to the Data Source tab and apply some data source filters. And they're very simple to apply. You just add the filter. A window opens up. You can decide what filter you want to add. And we're just going to put a filter order date. And then another window opens up. And this should look really familiar. This is beginning to look like the type of dimension filters you'd used before. And we decide we want to take a filter on years. And I decided that I only want to look at the last 2 years worth of data. And we can apply those, and you can see what it says. It says, well, I'm only going to keep 2 years worth of data, 2021 and 2022. And now when I go back to that tab, you'll see there's only data for those 2 years in there. And if we take a look at the amount of data that's in this worksheet, it's no longer 10,000 rows of data. It's now 6,000 rows of data, or 2,900 rows of data. So by eliminating 4,000 rows of data, this workbook is going to perform much better than it would have if it had a whole 10,000 rows of data. I'm going to set aside data source filters and extract filters. They're really no more difficult to use than that. You can use them to improve the performance of your book. But all the other steps in the order of operation work at the worksheet level, and each worksheet has its own separate data table. And I want to look first at steps 3, 4, and 5, and these are really where most users end up being confused and end up having problems, is in the application of context filters in relation to the creation of sets, fixed LODs, and top-end calculations, and then the application of dimension filters. The one thing to keep in mind, and it's always in the sequence, context filters are applied before fixed LODs, sets, or top end are created. Dimension filters are after. Well, if we take a look at that and see how that might work, we're going to look at this very simple data set. And whenever you're learning something new in Tableau, I would encourage you to use a very simple data set, something where you can do the math on the back of an envelope and see what is actually going on when you create a function. And in this data set, I got just two different types of, I've got fruits and vegetables, and in fruits, I've got 3 different types of fruit and 3 different types of vegetables. And I do a very simple calculation to get the total cost and then an LOD based on that total cost. I'm going to show you what that is. This is the total cost. It's nothing more than taking the price times the quantity. And then the LOD by type is just simply, I want a LOD that's fixed at the type level, either fruit or vegetables, and I want the total cost. So you can see here that my LOD is fixed at the type level. So it's $5.75 fixed, or it's the same as the total cost. And for vegetables, it's $2.63. Now you also notice here that I'm going to put a filter on produce name. And what I want to do is I want to filter out bananas. Okay, and I'm going to take bananas, I'm going to filter them out of the data set. And when I do that, we can see that the total cost is $3.75, but the fixed LOD is $5.75. And this is what we would expect to happen if we take a look. Oops, wrong button. Take a look here. The dimension filter, we're applying a blue filter, is applied after the LOD is calculated. So this value remains at $5.75. Okay, the filter on bananas was applied after that value was calculated. I could take this filter and add it to context, and I do that just by right-clicking it, add to context, and now it becomes a gray pill. And as the gray pill, I'm sorry, I'm getting pinged on something else that's happening right now in the world of Nashville. Okay, when it's applied as a gray filter, as a context filter, now this filter or bananas are filtered out before the LOD is calculated. And you see now the LOD returns $3.75. So what we've done is we've applied the filter on bananas before we calculated the LOD, and then the LOD is calculated. The same thing happens when we start taking a look at doing ranking functions, or we do a top-end function. And to do this, I just made a very simple set here. I just wanted to take a look at the top-end set for produce. And I just want to show you what that is. We're going to, right here, we're going to take a look at the in-out set. I'm sorry, somebody from Nashville pinged me and kind of knocked me off what I was doing. And it was, okay. We're just taking a look at the top end set, and we're taking a look at the top 3. Okay. And that's what this does here. In the top 3, the values that are in the set are apples, bananas, and green beans. And what's out of the set are grapes and spinach. And once again, we're going to come back and we're going to filter out bananas. And now I've got the produce name in context. So the filter is going to be applied before the top end are calculated. So when I take out bananas, and I'm just going to show you what's left in the set because it's easier to see that way. I still have 3 values in the set. Bananas are not one of them. We filtered out bananas before we calculated the top end. Okay. Now the 3 are apples, green beans, and spinach that are in the top end. Had I not put produce in context, and if I had left it in as a dimension filter, now I've filtered out bananas after the top end were calculated, after the top 3 were calculated. So I'm only going to return 2 values. Okay. The values that we're going to return are apples and green beans because they're the only 2 that are left. I'm going to put bananas back in here so we can see where it was. Bananas were here. Now we're going to filter out bananas after the top end are calculated. So there's only 2 values remaining. We get this question quite often on the form where where people write in a question, they say, look, I calculated the top end. I wanted to see the top 5 values. I'm only seeing 2 of the values. What have I done wrong? And it's all involved with where the filter is applied and when that, it's all involved with whether the dimension was placed in context, so it's filtered before the top end were calculated, or whether it's a dimension filter that's filtered out values after the top end are calculated. I want to take a real brief look at dimension filters, because this is probably the second thing that you learned in Tableau. The first thing you learned is how to drag and drop information onto a worksheet, and then you learned how to filter that information. And dimension filters are the easiest ones that we use. We end up using them quite often. This is that superstore data again, and all I'm doing is I'm taking a look at categories and subcategories over the 4-year period. And if we take a look at this, and I don't know if you're familiar with using that tab there, but this allows you to see the data that is in the visible data set, and I can also look at the detailed data. There's 68 rows of data in the visible data set, and you say, well, Jim, that's not really 68 rows. But if I make that long, narrow data set that Tableau likes to see, this works out to 68 values or 68 marks that are in the data set. The full data set, the data that's underlying this, is that 10,000 rows of data. It's all the data that's in the Superstore data set. Now, if I come back and apply a dimension filter on category and filter out the office supplies, for example, all of a sudden we've seen the visual change, but we've also changed that underlying data. So the data that's available to this worksheet is no longer that 10,000 rows of data. The visual is now 32 rows of data. It's no longer 68 rows of data. And this is what it looks like right there. And the full data set, the only data available for this worksheet, is now 4,000 records of data, or 4,000 rows of data. The other 6,000 records have been eliminated. They're not there. Okay. Now we get this type of question quite frequently, and it usually comes in the form of, I'm going to show a filter here on years. Usually comes in and the user will say, well, look, I've created this data set and I've got sales in here, and I'm going to do a very simple year-over-year calculation, percent difference calculation. And then I come back and I only want to see the last column, and I'm going to filter down to 2020, and all of a sudden I've got no data. What happened here? Well, if I'm calculating a year-over-year calculation, I have to have 2 years. I have to have 2019 and 2020. And 2019 has been filtered out. There is no data in this data table for 2019. And if we were to look here at the data, we can see in total, there isn't any. And if we look here at the detailed data, there is also no data for 2019. So literally what we're doing this portion, excuse me, literally we're doing in steps 3 through 5 of the order of operation is we're restructuring that data table. And we're structuring that data table so it contains only the records that we want to see in that worksheet. And consequently, it's the only data that's available to that worksheet. And what we've done in the first 5 steps is we've eliminated rows first from Tableau altogether at the workbook level, and then in the next 3 at the worksheet level, we further reduce the amount of data that's available. So we might go from 10,000 rows of data down to maybe 150 rows of data, and that's the only detailed data that's available to you. Now, once we've completed that, once we've completed creating the data structure for that worksheet, all we're going to do is we're going to fill that data structure with values. You know, imagine like you got an Excel table there and you've got headers on the rows and columns, and it creates a grid for you, and you've got a bunch of cells out there. All we're going to do is we're going to fill those cells with values. We're going to use some different types of math in here, using like include and exclude and the custom calculations that you make. We may apply some filters on the values, no longer on the structure of the Then we do some tables and maybe some table calculations and decide what the viz is going to look like. I want to look right now at data blending because this is an area that causes a lot of confusion with users at all different levels, not just new users, but users at all levels. And data blending is something that you would do if you're combining data from different data sources or data are at different levels of aggregation. And if you've ever written a question out there and you say, well, geez, I can't filter and I can't use LODs, what's the problem? And you probably got an answer back from somebody like me that says, well, you blended data. And because you blended data, your blending data takes place after the LODs have been calculated and after the data structure has been calculated and filters have been applied. Well, let's take a look at how that might look with some numbers here. This, once again, is the Superstore data set, and all I've done here is I've taken a look at sales by category, and we're looking by quarter. And I've also got some goals. I created another data set that we call goals, and the goals are at the year level. They're not at the month level, and they're by category. And when I bring the two of them together, and I just apply them together, I get something here that doesn't make a whole lot of sense. I mean, I got goals here in 2018 and 2019, and these numbers in 2018 and 2019 look the same, and it just doesn't make sense because I know the goals don't look like that. The goals are separate for 2018 and 2019. Well, what's happened here is we are blending data. And I'm going to go up here to the data source tab, and I'm going to take a look at the blend relationships. And a couple things happen when you blend data together. First, you create a link between the two data sources. And then second, all the data from the secondary source is aggregated at the level of the link. And you can see that the data here coming from our secondary source, which is our goals, is aggregated at the level of the link, which is the category level. We need to come back into this data set and create an additional link at the year level. And once we do that, we get our original goals. Back. Now, users will come back at this point and say, hey, wait a minute, I've got this data and I've got it blended and I want to apply some additional filters. And I want to apply some dimension filters that work across both data sets, both my primary data set and my secondary data set. And this is where a lot of users run into trouble because you just plain can't do that. After the step 5 in the order of operations, and step 5 is where the dimension filters are applied, you can no longer filter. There's no opportunity to filter back across those two data sets. And once again, the data coming from the secondary data set is always aggregated at the level of the link. You cannot apply a filter down here in steps 6 through 10 on blended data because all the filters have already been applied either as a context filter or a dimension filter. Now, and you say, well, in that case, what do? You have to go to a different data structure, like maybe a relationship model, or join the data sets together. The same thing is true when we try to do an LOD. You could try to calculate an LOD across the two data sets, and you'll get something that looks like this. We say, well, I want to look at the fixed segment level, and I want to sum the annual goals. And you can see when I'm bringing data from the secondary source, it comes across with this full citation. And I'll get a message that says, well, no, you can't do that. And this message is going to tell us, it says all fields in a level of detail must come from the same data source. Well, why is that? It's the same issue. Is fixed LODs are calculated in step 4 of the order of operation. Okay, that's before we have completed the total data structure, and it's before blending takes place. Blending takes place after the fixed LODs have been calculated, so you can't calculate an LOD based on blended data because it hasn't happened yet in the order of operations. Okay. I want to move on to two statements, and I just the last week, and as a matter of fact, yesterday recorded a data doctor on the include and exclude statement. And these were always very confusing to me. I've just got a new post out on my blog on include and exclude, and they're usually presented as the other two LOD expressions. And somehow when it's presented that way, we have a sense that fixed LODs and include and exclude statements are really kind of cousins of one another, and they're related to one another. And we can see that that's really not the case. They take place at totally different times in the order of operation, and they are operating on at different principles altogether. The fixed is operating on the structure of the data set, and include and exclude is working on the values within that data set. And I want to look at an example here of include using a very simple data set that I created, where I've got two different product lines. I've got a sports and a toys product line, and I got a couple different products in each one of them, and customers and by color. And I want to see what include does. And this is the data set again. And there's a few values here that I'd like you to keep in mind as we go along here. I'm just taking a look at the sum of quantity. That's all we're doing. We're just looking at the sum of quantity here. And if we take a look at customer one and we take a look at his total over the sports one, there's 25 units, and then for sports two, there's 24 units for a total of 49, and so on and so forth. Then we're going to take a look at what happens when we start looking at the average of those values. And I want to look at just the simple average. The simple average, which is what I would get by just dragging quantity onto the canvas and then aggregating it with average. The average here is 12.5 and 12 and a total of 25.25. I can also create an include statement to look at those values. And I'm going to show you what that include statement looks like. It's just very simple. It says, well, include the product one level, include this level, and then sum the quantity. And then we're going to come back and we're going to take the average of that. And if we take a look at that, we can see, well, down here at the color level, these values are the same. Well, what are you showing me, Jim? They're the same values. So the average quantity, and then there's this include statement. They're the same values. But let's take a look at what happens when we start totaling these up. As we go up the hierarchy at the next level, all of a sudden we see a change. Our average quantity, our simple average quantity, is now for customer one in sports, it's 12.5. Where the average using the include statement takes the average that we were looking at previously of the 25 and the 24 and gets 24.5. And if we go up one more level, we're seeing here's the 24.5 and the 31, which comes from the toys, the same type of notation here. Taking the average of toys, which would be 35 and 27, okay, and gives us that average, okay? So the include statement works very different when we're looking at averages than taking the simple quantity. Well, why would you ever look at that? Why would you ever do something like that? Well, I spent a lot of years as a product manager, and as a product manager, I'd like to look at my product line at different levels. I'd like to see what the simple average was. If I take a look at each and every SKU, what was my average sales? Well, it was 12.5. Well, if I take a look at my product level, what was my average? Well, the average at the product level, if I'm disregarding, if you will, color, if I'm going above the color level, my average at the product level was 24.5, which would mean a whole lot to me as a product manager on deciding which items I'm going to keep in the product line and which items I'm not going to keep in the product line. Well, if that's what include does, what does exclude do? And I always go back to this map, and I realize you're not in the US, but sorry about that, but I always go back to this map, and this is a pretty simple example to understand. Exclude does it allows us to take a look at a viz that's already created. We're looking at a data set that's already created, and we're looking at the viz that results from that data set. And what I'd like to do is I'd like to go back in and I'd like to take a look at excluding the I want to take a look at what the sales would be at the next higher level above state. Now, if I look at our viz here, we've got region and we've got state. We've got regions are made up of states, and I want to exclude the state, and I want to see the total sales at the next higher level, which in this case would be region. It doesn't have to be, in this case, it is region, but it could have been territory, or it could have been, sales group, or some other dimension that I would put in there. And literally, what we're telling Tableau to do here is look past the state level and don't use state when you calculate the sum of sales. And when we do that, and I'm going to show you what those values are now, we can now see the regional sales and the state level sales at the same time on the same viz. And then we can come back and we can also go in and we can calculate the percent that the state level sales is to the region level sales. So include allows us to look at different levels in a hierarchy, and exclude allows us to take a dimension that's already on the viz and not include it in a calculation. And I hate to say the word ignore. Users say that all the time. They say, oh, I want to ignore that dimension. Tableau doesn't really ignore dimensions. You as a developer, you decide when you want to apply filters, when you don't want to apply filters, when you want a dimension included in a calculation, and when you want to exclude it in the calculation. We got a couple of other topics to run over rather quickly here. I want to talk about measure filter. Measure filters are the other type of filters. They work on the values in the data set. And we're going to use this same data set that we've been using here. And we're looking at the sum of quantity here. And I want to filter based on the quantity itself. Now, when I bring quantity to filter, this box opens up. And it's literally asking the question, this first highlighted value or bold value at the top is literally saying, do you want me to filter at the detail level in the data set, the detail data, or do you want me to filter at the aggregated level, or the value that you see in the data? Let's look at the detail level first. And I want to see all the values at the detail layer that are between 1 and 15. Okay, and we put that in. Now we say, well, wait a minute, Jim. You just did something here. I want to show the filter. You just said I want to see values from 1 to 15, and there's a value of 24. Well, where did that value of 24 come from, and why is that value there? Well, that value comes from the detail data. We are filtering at the detail level, the underlying data. You hear us talk about the underlying data, or the underlying data table. That's the detail level and not the summary level that you see on the screen. This is the summary level. This is the detail level. And you can see here there are no values greater than 15. When we bring that to the viz and we aggregate it using sum, okay, we see this value of 24, which is 15 plus 9 is 24. We could have done the same sort of activity, and we could have looked at the quantity, and we could have filtered on the sum, or the value that you see on the screen there, and come back with the same 15. And now this filter is applied to the visual that you see, and there are no values greater than 15. Okay, so we have our choice when we're using measure filters. Do we want to filter at the detail level, or do you want to filter at the level that's in the viz? We're going to take a quick look at totals, and then we're going to take another quick look at table calculations. Grand totals. Grand totals can be used to calculate subtotals. They can be used to calculate overall totals. But it's important to understand that they are not calculated the same way that totals are done in Excel. In Excel or any spreadsheet, the totals are calculated by simply summing a column of individual cell data. when you apply totals in Tableau, we're actually going back to the base data and recalculating our totals. When we come in here, we can create totals by going to the Analytics tab, totals, and applying totals in terms of the column, and we calculate the total for each column. Okay, and we've actually gone back to the base data and we've summed those totals as we go along. Now, one of the things that we very often do is we'll take a look and we'll say, well, what I'd like to do is I'd like to calculate the percent difference year over year, and I want to calculate a total on that. And this percent difference is nothing more than a simple calculation. We're going to look at it in just a second. That takes the difference between two values and divides it by the initial value. So it ends up being the percent that you see here. But you see, there's no value for the total. Well, the percent difference we're calculating, and this is calculated down, is the difference between this number and this number, which is the 37%, and this between that number and this number, which is the minus 42%. But mathematically, there is no total. There's nothing that makes sense there, so you'll get no value here. So very often, you'll find out that grand totals and totaling doesn't produce maybe the results that you expected. Now, there's other ways, and there's more detailed ways to go back in and calculate the grand totals. This just calculates. These are the totals going across the page, and these are the averages coming down the page. And if we take a look at value number 9 here, we're taking this. We've done a calculation that says, look, if size equals 1 and size equals 1 is a property of the grand total or the subtotal line, it just says there's only one record in there. If the size equals 1, then sum sales. If not, then take the average of this LOD expression. This LOD expression says I want to be at the region level, and I want to take the region, segment level, and the sum of sales. So for each region and each segment, sum the sales, and then take the average of those to calculate this value. Okay, so it's going to calculate that value down. This comes across, and then this average is coming down to give us the average of those 4 values. Okay, now I'm only going to touch the surface of table calculations. Table calculations could be a course in itself. We find that most users, particularly coming from Excel spreadsheets or any type of spreadsheet calculator, are very comfortable with the concept of table calculations. Very similar to what you did in Excel. Very similar to creating a formula and that resides in a cell, and then copying that formula throughout all the cells in a row or a column. When we talk about table calculations, we talk in terms of 2 properties, scope and direction. Scope is how much of the table is going to be used in the calculation, and direction is, are we calculating across the table or are we calculating down the table? And that's kind of the same thing you did when you made an Excel calculation. You made a calculation in a cell, and then you copied it either across the table or you copied it down a column within the table. Table calculation is very easy to do. If we had a data set like this coming from our Superstore data set, and I wanted to calculate the percent of total, there are default quick table calculations that allow you to do that. It's a percent of total, and I can click on that, and lo and behold, we get the percent of total. But the first thing you're going to see is that, hey, that's calculated with the direction across the table. This total over here is going to equal 100%. If I were to drop in totals, we're going to get 100% this way. But that's not the data that I wanted to see. I wanted to see it going down the table. Tableau will always default the direction to across. You can change that by opening up, by right-clicking the pill here, that little delta, and compute using down the table. And now these values are calculated down the table. So we're getting the percent of total for each one of the months of the year. And if we were to drop this in and look at it like that, we now get a total of 100%. Now, if you remember way back when we started this, we talked about the order of operation. And in the order of operation, we talked about where fixed LOD expressions reside up in step 4 of the order of operation, and where table calculations reside in step 10 of the order of operations. And I said, well, you can't take a table calculation and use it in an LOD. But the reverse is true. I can take an LOD, the results of a fixed LOD expression, and use it in a table calculation. And very often we'll get consumers, or we'll get a user who writes in and they say, hey, look, I want to calculate my percent, or I want to calculate a ranking, and I want to see how that ranking by subcategory, by segment, by year varies across a 4-year horizon. Well, the first thing we need to do is we need to calculate that what those values are, what the LOD itself is, and I'm going to calculate this thing as this right here. And in words, what this says is take all the combinations of the segment, the subcategory, and the year of order date. And there's 3 of those, and there's 17 of those, and there's 4 of those. And for each one of those 204 points, sum the sales and save it as this LOD segment subcategory so that I can use it later. And that's exactly what's going on here. I've created another layer in my data set at the combination of subcategory, segment, and a year of order date. And these are the total values at that level. Now, what I want to do is I want to come back and I want to calculate a ranking based on those. And ranking in all its various forms are table calculations, and you can see them here. This is the calculation wizard, and if you open this up, you can see that rank unique is the one that I prefer to use, but you can rank in a number of different ways based on whether it's a competitive environment or rank dense, rank modified, or whatever. But I just want to rank, and here's my LOD expression, and the LOD expression itself results in a layer in the data set, but that layer in itself is not an aggregate. So you can use it anywhere in any other calculation. And when I use it in a table calculation, it has to be aggregated. So I do the sum of that LOD, and I want to rank that descending. And if we add that to our data set, okay, and it certainly looks messy, and now I'm just going to look at the detail. The first thing you're going to see is that, once again, Tableau defaults to going across the rows, and that's not what we want to see. And I can open this up, and I can go to the Edit Table Calculation command, and it opens up a wizard. A window opens up, and it's going to help us decide both the scope and direction that we want to make our calculation. And you can see the highlighted value here. The calculation assistant is across the table, and it's all the way across the table. What I would like to do is I'd like to vary that. And if I come down here to specific dimension, I can determine how I want to execute that calculation. You can see if I pick everything, I've got the entire table. So I get values 1 through 204. That's the highest value, and that's the lowest value. But that's not what I want to see. What I want to see is that every time this segment changes, every time I'm in a new column of data, I want that calculation to restart again. So if I calculate by segment, now all of a sudden I can see that phones were first in consumer, in corporate, in 2017, and by the time you get to 2020, they were first in consumer, but they were 4th in corporate. And I can use this, and I can nest this inside something that might look like this, and we can apply some color to it. That now makes it pretty easy to see what my number 1 subcategory was by year, by segment. Table calculations have one other property, and they can be used like an offset in Excel to navigate a data table. And there's 5 functions that allow you to do that. And they are first and last, and first and last pertain to either the first row or column in the data, or the last row or column in the data. And now we're talking about the visual data, the data that you see on the screen. Index counts across the rows or counts down the column. Previous value looks at the immediately preceding value in the same row or column. And lookup literally says, hey, from this cell move so many cells either across the table or down the table, and return the value that you see there. Now let's take a real quick look at a couple of those examples. And this column here is just for reference. I'm just taking a look at the sales by subcategory. And if we were to take a look at this most simple example, this just says, in terms of a lookup function, go to that column that's called sales, go to the column in the data that's called sales, and return the value that's one previous to the location that I am in my new column. And we're going to look here, and we're going to say, well, I want to go to the column called sales, and I want to return the one previous, which would be this value right here. And then this value is the previous value, which was the appliance value. And this is the art value, and so on. Go back one value. Up, if down is positive, up is negative, and that's where the -1 comes from. I could also write this as return the first value in that column called sales, first being the first row in the data set, and last being the last row of the data set. Okay, return the first row of the data set. So I'm going to get this value of 167,000, or the accessory value, in each and every case. Or I could write a formula that would look like this, that would say, based on my current cell, take the value in my current cell and subtract from it the value of the first cell in sales, and would return values like that. Most of the time, I end up writing my own lookup, my own table calculations. It takes a little practice to get used to how they work, but you'll find after a while you can nest them very successfully. This is an example using the previous value. You know, and I said previous value looks in the same row or column and returns the value that's there. I want to start by just taking a look at the previous value. This just says if the value of the column called sum of sales, or sum of value, if the value is null, return the previous value. So here, as we go down here, the previous value is not null, so I'm going to have the value of 100, here 200, and here it is null, so I want the previous value, which is 200, and here it's null again, and I want the previous value, which is 200. And then this is just going to total, of course. This is going to allow us to create a running total based on previous value. And it's going to take a look at this column of data, and it's going to add the previous value to it. So I get 1 + 2 is 3, + 2 is 5, and so on. And it's a way of using previous value to calculate a running total. Now, there's one other property involved in this last level of the order of operation. And that's the use of show hide filters. I'm sorry, my phone was just going off. And that's how to use show hide filters to hide part of the data that's the result of a table calculation. I've calculated a running total here. And this running total, and you probably have done this, and we've certainly had a lot of users do it. It's just a simple table calculation. And we can see it here, right here, and it just gives us the total running down the page. the same way I did with that previous value example, but this was the running total going down the page. Okay. And now our user will come back and will say, very typical user say, that's fine, but I only want to see the last 12 values. I don't want to see the last year. I don't want to see this entire graph. I just want to see part of the graph, but I don't want it to start again at 0. And if I just, if I just put a, if I just put the order date on this and years, and I just look at 2022, the last order date, it's going to start again at 0, and that's not really what I wanted to see. Well, how can we get this thing to show us 2022, but starting at where January was, which is somewhere in the neighborhood of 600 or 700,000 values? And we do that with what's sometimes called a table calculation filter, most often used as a show hide filter. And here I've used the last function. I said if last is less than or equal to 12, then show, otherwise hide. I'm going to show the first values here. Okay. And there we go. And now we're just seeing the show values, which start about 700 and go through 1200. But we haven't lost the fact that the other data that we've hidden away here is actually in our table. We're just plain not looking at it. It's like taking a window and moving it over your data and just looking through the window and saying, I just want to see that part of the window. And I know there's other data that's still part of that table, but it's just not in the window that I'm looking at right now. Okay, I know this was rather quick. The order of operation is probably the single most important concept you can learn, not just as a new user, but also as an experienced user, because it's the source of most of the problems when you're just sitting there and saying, I didn't get the answer I wanted. And it's probably because you're trying to do something out of the order of operation. Remember, it starts with data coming into Tableau. You then create a flat file or a flat table dimensionally in steps 3 through 5 of the order of operation for each one of your worksheets. And then all we're doing is filling that data table with values and doing some calculations and deciding what the business is going to look like. I have some time for questions. I'm going to stop sharing my screen now. So Tori, if there's some questions, go for it.
It's up to you guys. Anything? There's nothing on the chat so far, at least. Everything was clear as crystal, I assume. You know that the Norwegian user group are probably the most, clever people in the world.
Well, they're obviously much more advanced than the Nashville users group, because usually I get a whole lot of questions at this point.
Or it could
Okay.
be shy, I'm not sure. Any questions, or was it?
I could get a comment. It was very useful. It was a very good presentation.
Yeah, they liked it.
Okay. Tori, you might just mention, and if anybody wants to go out, and the entire 0 to Zen series all of that is out on my blog. If you go out to jimdehner.com, you can find it out on my blog. Look under presentations or look under the individual sections themselves, but you can see what's been listed out there. I'll just put I'm not going to send this to you, Tori. I'm going to send it to everybody. I'm going to send the.
Yeah, I'll share it on my screen as well.
There, and that's how you get to my blog. So and from there, everything else is connected. You can get to the get to my Tableau public site or anything else. Thank you for this opportunity to speak with you today. I wish I could join you for adult beverages here shortly, but it's still too early in the day for that here where I am, and you've got more meeting to go at this point.
Thank you, Jim. Have a nice day.
Okay, thank you very much. I'm going to leave you now.
Då Det tar bare 2 minutter, så dere kan få lufta dere og fylle på litt. Toalettet ute I gangen til venstre, så dere ikke så det når dere kom der med heisen, hvis noen trenger det. Hvis du Roar, du jo der. Jeg skal se om jeg finner det. Sånn. Ja, var det mye nytt for deg, eller har du kjent, eller? Det den måten du skulle bruke det på?
Mer krevende å formidle det til noen som skal forstå det som ukjent.
Ja, det det. Det jo ingen tvil om. Men den order of operation, jeg helt enig med det som han sa. Det gjør jeg når jeg holder kurs. Den print ut den der rekkefølgen og se hvor level of detail, fixed, exclude, include, kommer ut forskjellige nivåer det hierarkiet, og så ha den tilgjengelig. For det, når du skjønner det, da skjønner du litt ofte hvorfor ting